Alright, so I've been thinking about a way to kind of summarize some of this together or get some extra practice, or think of a different way to even go about teaching some of this stuff. Trying to catch up with some of our info for Unit 6 on that unit circle, and making more sense of what we see here. Our key, really everything on this front page that we've got here, is a big key to what we're studying. So we've been adding our little notes here about how our x-coordinate is cosine and our y-coordinate is sine, and how if we make a larger circle with a bigger radius, our coordinates are also going to have to move outside of what we see here. So there's a lot of stuff that's kind of here and going on, but it's nice sometimes to step back and also see what it all means. So thinking about our first couple lessons, we were really thinking a lot about how each of these values can become a triangle. And we haven't come back to that idea for a while, because once we start having our unit circle and the values here, the triangles, all of our information is really on the unit circle. So I just want to kind of bring back this idea of what it is that we're actually solving and working on. So we have a coordinate grid and just like any coordinate grid, we have some values vertically and horizontally. So here's my quick kind of full coordinate grid going on. What we've really been looking at so far is drawing a circle over top of this grid that has a radius of 1. So if it's 1 unit, I should have another one up there, sorry. If our radius is 1 unit, it's kind of a squished looking circle, but it's okay, you get the idea. Our radius being 1 unit is really going to start us off with some thinking about some different angles as we move around. Now, even if I take that angle here, which is always going to be our starting point, and if we start to rotate it to some different angle measures, like something like that, we can see that it's still on a coordinate grid, and we can still always make a triangle out of it. Now if our radius is 1 and we took that radius and just moved it to a different spot, this time our radius is looking like this. So taking still that same length and just twisting it up here. Now we have this angle measure here, and we have an x and a y coordinate. Both our x and our y coordinate are going to have to be less than 1. Clearly, it's easy to see on the x-axis because 1 is all the way out here, and this side of this triangle is definitely not that long. So we know that our x-coordinate is going to be less than 1. It's really the same thing up here too. On our y-coordinate, if we think about all the way up to the top here is a radius of 1. This one is not getting quite that close. Is not getting all the way up to 1, so it's going to be shorter and less than 1. And so we can start using an angle measure and our values of the opposite side and the adjacent side to start using these trig functions to help us out. Now, sine and cosine, where we started our conversation in this unit, we were talking a lot about SOHCAHTOA. Sine is the opposite side over the hypotenuse. So the sine of this angle is the opposite side over the hypotenuse. But the hypotenuse is just 1. So it's really just the opposite side of that triangle. It's how far above the x-axis we are. And that is our definition of what our y coordinate would be. So the sine of the angle that we're looking at normally looks at the opposite side divided by the hypotenuse, but the hypotenuse equals 1, so it's just going to be our y coordinate, our opposite side. And our cosine then is the adjacent side over the hypotenuse. But again, that adjacent side divided by our hypotenuse is 1. So this adjacent side divided by 1 is going to be itself. It's going to then just be whatever our x coordinate is, because we're looking at how far over we're moving away from the origin on the x-axis. So that's kind of a good review about why x is associated with our cosine value and sine is associated with our y coordinate. When we know that kind of stuff, we're then going to start seeing how we can take the same angle and bring it into some different quadrants. Over here on our x and y axis, we can see that we're moving to the right, which is a positive x, and we're moving up from the x-axis, so that's a positive y. So that's why both cosine and sine are positive here in quadrant 1. Now, as soon as I take that point, or that angle, and I reflect it over here into quadrant 2, I see that these have the exact same y value. See how they're hitting on that y-axis at the same place. So this will have the same sign, the same y coordinate. Oh, I didn't mean to put that parenthesis there. And if it has the same opposite side here, the same y coordinate, and the same hypotenuse, really what we have is the exact same triangle, just reflected over. This time though, our x is going to move to the left of the origin, so we would just have that same x coordinate but negative. So the same cosine, but it just turns negative here in quadrant 2. Reflecting those same things to each of our different quadrants, right? I can also reflect it down this same point, and if I keep the same x coordinate, it's going to bring it down in here into the quadrant 4. Now that's going to keep that same x. So it's still going to be a positive cosine of our angle here. And our same value is what we have in quadrant 1, just reflected straight down. And again, if we know we have a hypotenuse of 1, because it's a unit circle, it's going to have the same radius all the way around every point that's on the unit circle. If we have the same x coordinate, it has to be the same y coordinate. Triangles just tell us that, this idea that a squared plus b squared equals c squared. Well, if c squared is the same everywhere, and if we have some values that have the same x, right, or a squared here, this side right here, the short one, that means that this side has to be the same. It's just that our sine is negative for our y-coordinate because it's going downward from the x-axis. So that's kind of our idea behind these positive and negative signs. Are telling us that cosine is our x, and it's positive in the first quadrant and in the fourth quadrant. Now, I don't think I said this in our class. I know I said it in the other one. There is a nifty reminder about which ones are positive in which quadrants. So this big old positive sign right here in the middle. See that big old plus, positive? And we talk about all students take calculus. So the same way that we always start here and go around, the same way we also count our quadrants, quadrant 1, quadrant 2, quadrant 3, and quadrant 4. All students take calculus tells us what of our trig functions are positive, big old plus right here, in each of those quadrants. So in quadrant 1, all of our trig functions are positive in quadrant 1. Sine, cosine, tangent. All of them are positive. In quadrant 2, that S is telling me that sine is the only one that's positive, which tells me cosine and tangent are going to be negative values here in quadrant 2. All of them in quadrant 1, sine in quadrant 2. Tangent is the only one that's positive here in quadrant 3. So sine and cosine are negative. And in quadrant 4, cosine is the only one that is positive. That means my other two, sine and tangent, are negative. Now this kind of stuff starts to come up because we can then say something like, well, I have an angle in quadrant 4 that has a sine value of negative root 3 over 2. What is the cosine value? So we can start to use that information. We want to first of all take every bit of information that it gave us. It says, first of all, I'm in quadrant 4. So I personally, when I was first learning this, would actually physically block out all the other quadrants. In quadrant 4, we said that we know the sine value. Sine is our y coordinate. So if we said the sine is negative root 3 over 2, I'm looking for the place where my y coordinate is negative root 3 over 2. And so I'm finding if I needed to name that angle, it would be 5 pi over 3. So just using that unit circle printoff, I can tell what angle measure it is. And now if I want to know the cosine, I can find it. Cosine is just this same coordinate, or the same coordinate pair, but I want the x coordinate because it's asking for cosine. Now, with any calculator, now I'm not sure what kind of calculator you're using, so I'm just going to use the little pocket calculator. We want to first of all check that we are in radian mode, because everything we're going to be doing in here is in radians. So right now, mine is in degree mode. It's kind of hard to see. Let me hit focus real quick. We'll see if that helps. There we go. I'm in degree mode. So in this kind of calculator, it's right up here, DRG. And I can go over and make sure that I'm in radian mode. So being able to calculate and use your calculator is a really big deal. If you have a graphing calculator, your mode button is the one that's going to tell us which mode we're in. And actually you can look right up at the top and it should tell you. Mine says I'm in radian mode. If you're not, or you're not sure, go to mode, and it should be one of the first couple ones up there. See where it says radian and degree? You want to make sure that radian is highlighted. If it's not, hit enter while radian is blinking like that. And then we should be all set. So you can quit out of there. Second mode will take you right back out. So if you weren't sure, you could say, well, hey, if I'm in quadrant 4, and I know I have a y coordinate, a sine value of negative root 3 over 2. Well, I'm suspicious that it's 5 pi over 3, and so I could even check with my calculator. If I want to make sure I'm at the right angle, I could type in sine of 5 pi over 3. I'm going to do this with both of my calculators so you can see how we'd be doing it. So when I hit sign, it opens up parentheses. The pi button is here above the exponent. So second exponent. Oop, I'm sorry, but I want a 5 pi. So I want 5 pi divided by 3. And this negative 0.866 is equivalent to this root 3 divided by 2. See how I have the same decimal? So I know for sure that I'm looking at the right angle because it's got the same sign value that I have here on my unit circle. So if I know that that's the sign is square root 3 over 2, negative square root 3 over 2, I can find the angle that goes with it. I can type it in my calculator to make sure I've got the right thing. And then if I just want the cosine of that same angle, I want the x-coordinate of that same angle, I would just then go for the cosine of that same angle measure in radians. Positive 0.5, positive 1/2. If you're looking more at something like our little pocket calculator, we can still type in the sine of 5, and this one actually has its own pi button, which I really like about it. 5 pi over 3. And I can again see that it's that 0.866. So given like a quadrant and an angle and a coordinate, I can find the other coordinate. So if I were to say, find the two angles in radians that have a cosine value of positive 1/2. I'm going to write this down so you can kind of think about how we would go through each thing. We need two angles. So I know now I'm looking for an angle measure in radians. Two angles that have a cosine that equals positive 1/2. I would start in my first quadrant, and I'm looking for a cosine angle that's positive 1/2. I'm looking for an x-coordinate that's positive 1/2. And I'm just looking at my x-coordinates. There it is. This guy. Pi over 3 is one of the angles that has a cosine value of positive 1/2. Now the other one that has a cosine value of positive 1/2, I would be looking here in quadrant 4 because cosine is positive here in quadrant 4. So again, I'm going to scan just the cosine values, just the x-coordinates, and I see there's my other guy that's got positive 1/2, 5 pi over 3. And notice that they're in this nice perfect straight line right on top of each other because they have the same cosine, the same x-coordinate. So we can start using some. If we needed to name all of the angles that have a negative sine value, I would say, okay, I need everything with a negative sine value, a negative y coordinate. All my y coordinates here are positive. All my y coordinates here are positive. So it's none of those angles up there. And when I look at all of my y coordinates down here, because I want negative sine values, I see all of these angles have negative y values. So our connection there about sine and our y value. Now on our quiz tomorrow, one of the questions is going to be, some of them are just going to be that kind of idea, like, hey, what is the sine value of 3 pi over 4? What is the exact version of the sine value of 3 pi over 4? You could go to your calculator and you could type that in. The exact sine value of 3 pi over 4. Now it's going to give me a decimal, but we have written down here about our decimal equivalents that if our decimal shows up as 0.707, the exact value that represents that is this square root 2 over 2. The other way I could go about it is to go find 3 pi over 4 on my unit circle. And if I'm looking for the sine, I'm going to look at the y coordinate. That's all I need. I'm going to ignore the x coordinate because it didn't ask about cosine. It just said, hey, what is the sine value of 3 pi over 4? Well, it's root 2 over 2. Our other big question is going to take into account back to these triangles, a squared plus b squared equals c squared. But if we know each of these triangles, instead of adjacent and opposite, a squared and b squared, we now know that its cosine squared is our x coordinate. So cosine of our angle is our a squared. Sine squared would be our other side, and our hypotenuse is still 1, as long as our radius is 1 on the unit circle. If our radius changes, really we have this same idea, and I think we wrote it down here on my paper, I at least have it here, that sine squared plus cosine squared equals the radius squared. So on our quiz, it's going to ask us, it's going to give us some kind of sine or cosine value and some quadrant and say, hey, all right, here's our big question. Let's say that I know that the cosine of some angle equals 0.15 and that that angle is in quadrant 4. What is the sine value of that angle? So it's telling us that one side is 0.15. Cosine, the x-coordinate is 0.15. Now I see that it's moving in a positive manner, so I know that I'm looking an x-coordinate in a positive manner. It's going to be somewhere in quadrant 1 or quadrant 4. So I'm going to block out my other ones because it better not be anything over there. It actually even tells me that it's in quadrant 4. So I'm even going to look down here. Now I have to know that because that tells me that while my cosine is positive, my sine value is negative. So I'm going to start by just knowing that my sine is a negative value. We'll see why that's going to come up in a moment. Now 0.15 is not showing up in here as a value. 0.15 is not one of these select angles on my unit circle. But I can still use Pythagorean theorem to make this happen. A squared plus b squared equals c squared. 0.15 squared plus my unknown side squared equals my hypotenuse squared. I have one unknown value, and it's okay that it's a whole entire trig function. It's still, I can tell you what that there's going to be a specific number that is that sine value that I could plug in. So it's just like finding an unknown variable. Okay, I don't know what the sine value is. I don't even know what the angle is. Okay, I know it's tiny because it's only moving just a little bit off the x-axis. So it's going to be somewhere like down here somewhere. I don't even know where. But it doesn't ask me to calculate the angle. It just asks me to find the sine value. So I'm going to start with the math that I do know. 0.15 squared. And notice that I'm putting it in parentheses. If it was a negative number, I would want that negative inside the parentheses. 0.15 squared is 0.0225. 1 squared is just 1 times 1. So that's going to equal 1 there. Now I'm just going to use good old-fashioned algebra and start moving things from one side to the other in order to isolate the thing that I don't know, which is whatever this sine value is. It was adding with 0.0225, so no, I'm going to subtract 0.0225. 1 minus 0.0225 tells me sine squared equals 0.9775. Now this is some value squared equals 0.9775. When I take that square root, remember that something squared has two possible answers, a positive one and a negative one. A negative answer and a positive answer. So when I go to take the square root of both sides, I need to think of either the positive or the negative answer to this. Right? So it would be something like if we had x squared equals 4. Well, there's two answers I could have for that. X could equal 2 or x could equal negative 2. Right? It could equal, so when I took that square root, x could equal the positive or the negative square root of 4. Square root of 4 is 2, but it could be the positive 2 or a negative 2 because of that square root, because it started as x squared. So same thing here with the sine squared. I have to think that it could be positive or negative. But we also know it's in quadrant 4, and we already said that it is definitely negative. So because of this quadrant, that tells me that it's a negative value that I'm going to use. So our last step in order to solve something like this is I need to do the square root of my answer. So let's set that up. Square root. And I can pull my answer right from here. So if you don't want to type in all those decimals again, you can just hit second negative sign. It will take whatever my most recent answer is, and now it's going to square root that. So when I square rooted it, I got 9.89-ish. Let's just go to 3 decimal places. And that is my sine value, negative 0.989. Now to see if that just makes sense, I had a cosine angle. It was in quadrant 4. It was a pretty small x value, cosine, pretty small, 0.15, compared to this whole radius of 1. And so I needed a very large, in comparison, y-coordinate going down in the negative manner. So that ordered pair would be 0.15, comma, negative 0.989. We could find that sine value by using Pythagorean theorem. All right. I hope that that's helpful. We went through a couple more examples, and maybe some of that practice on Khan Academy will also help you out to see if you're on the right track. There's some Khan Academy videos too that you could watch that would also maybe explain it in a whole different way. So there's something to get you going, but if you need more, we can hook you up with like a peer either in our class or from National Honor Society, or I'd be happy to work with you after school. I have to look at my calendar, so I might send you a couple dates that I'm available if you wanted to have a one-on-one meeting where we could just talk back and forth. Okay? All right, hope that helps.